Hm?
Oh ja, maar ja.
Ja, dan is het niet zo heel erg. Die is goed. Terminal.
Oh, maar waar moet ik in? Screen.
Rechts.
Wat staan ze nu? Als je hem ook ziet. Waar zijn die andere? Oké, ik heb
Midden, links, rechts. Dat is wat ik heb.
Anders scroll ik een keer de goede kant op.
Ja.
En die dingen voor jou. Oké.
Tuurlijk. Kijken of deze laat. Dat doet hij. Oké, cool.
Oh, what the fuck?
3 vingers.
Ja, dat had ik. Die kant op. Ik had 3 vingers, maar het is zo. Ik heb ook 3 vingers, hoor, dus dat is de same thing.
Mooi. That's working.
Nog gesproken? Gaan de vingers omhoog, zitten buiten omhoog van de...
Ze hebben volgens mij altijd blaadjes, maar je moet zeggen dat je ook een knoppen. Nee, nog geen week op. Dat klopt. Ja, dat is wel echt later van de zondag hoor. Een beetje dood is.
Bring the magic.
Hm?
Bring some magic.
Zo is het.
Laat me klaar hier.
Wat?
Deze top is goed klaar.
Heel veel klaar, ja. Yeah, we will.
No, we will switch roles really. So one off, one down.
Yeah. Maybe just doing questions, but then we'll make sure to both of them here. Awesome. Thanks. Will you be holding up the timing sheet? Yes. So you do 10, 5, 2,
Very good.
10
Okay.
Ja, dus we hebben, oké, 10 en 12 voor nu, dus dat is aan het
No, thanks.
Dus is prima. Ja, dat is wel absoluut volgens mij. kun je ook niet omvallen. Dat is wel fijn.
Ja,
Dan had ik wel heel stuk gelachen. Hey Dominic. Dat is mooi. Dat is mooi.
Ik heb er ook niet mee staan.
Ja, dat is wel goed, ja. Dat is wel goed.
Kun je er gewoon op.
Ja, dat is niet verkeerd. Dat is zeker niet verkeerd. We hadden geen driedubbel houdende rij, maar...
Jammer, maar we doen het op staan. Niet dat dat echt lekker is.
Nee, het is ook niet dat het leeg is.
Nee.
Trois minutes. 3 minutes.
Yeah.
You good?
I'm good, thanks. Thank you. Good afternoon. Thank you all for being here. My name is Stan. This is my fellow magician for today, Peter. We are both red teamers at a company called Outflank, which is a company based in the Netherlands. And today you are here at the MS Office Magic Show. So, a magic show, what are we going to do? We are going to show you 3 illusions that build on offensive tricks in MS Office. But, well, since we're hackers, we're actually gonna brutally violate the code of honor for magicians, and we're actually going to explain all of our tricks after showing them. That's my intro. Let's dive straight into the details, because it's going to be a really fast-paced talk. Plenty of material in here. So if you have any questions, feel free to come to us after the talk or reach out to us on Twitter. I'm going to do the first illusion, and every magician should have an illusion in his playbook where he makes things disappear. So let's start there. Let's make a macro, let's make our evil code disappear. It's a basic trick. So, what we see here is demo1.doc. It's a Word file. I double click it. Word opens. The MS Office Magic Show, thanks. There's the famous yellow bar that says, hey, there's macro contents in here. Do you want to enable this? And of course I want to enable this. And as you can see, macro code runs, a calculator pops, a message box shows. That's it. Okay, let's close this. And now let's first of all look, where's the macro in the GUI? I don't see no macro in the GUI. It's not here. But we all know not to rely on the GUI for this kind of things. Let's go to my analyst tools. I don't see no code. What's happening here? So I hope you're all puzzled right now. What the fuck happened? If yes, let's start. So this builds on a few offensive tricks. The first one is, how do you hide macros from the GUI? I guess that most of you are familiar with what a OLE compound file is. That's what you're seeing here. So if you look at the Office file format for 97 to 2003, it's the OLE compound file format, which basically consists of storages and streams. It's like a file system. So what you see here is there's this Word document, demo1, which has a storage called macros, which has a storage called VBA, and within that storage, there are a few streams. And the interesting thing is that the stream instructing the GUI what to display is in the stream project, while the actual code that is going to run is in other streams, in this case in module 1 and this document. So it's really silly, but hiding from the GUI is as much as opening the project stream, which is basically a text file, and just removing your modules from there. So the line that you see highlighted there, module is module 1. If you just remove it, then thereby the GUI from Microsoft Word doesn't know that there's a module to open. Hiding from the GUI is as easy as that. But then you say, how do we hide our stuff from the analyst tools? Let's look at this output. Output from, in this case, OLE tools with OLE VBA. How does a tool like this work? It opens the potential malicious document. It sees that it is a OLE compound file, so it will see if there's a VBA storage in there. Yes, there is. And then from the relevant streams, like in our case, module 1 and this document, it starts carving out the relevant code, and it will display that to the console of the analyst. Okay, so one of the questions that we have to ask is, what about input validation? Can we actually trust a malicious macro? Well, definitely not. So let's see what we can do here. What if we just insert backspace characters in comments after our lines? Yep. I have tested this on a number of tools, including Oli tools, Oli dump, and all your favorite tools, and many of them, actually most of them, are vulnerable to this. I've reached out to the most important ones, including Oli tools, and there will be a fix there, but please help us spread this to other tools that are being developed in this area. So this is fun. But in the illusion that I showed you, I actually used another trick. And the other trick that we use there is what is called P-code. And I guess that many of you have already seen the excellent talk by the guys from Walmart yesterday, where they looked into what happens with P-code, especially from a defensive perspective. Well, as we are red teamers, we have looked into it mostly from an offensive perspective. And what you need to know is the following. It's a really quick summary about P-code. So if you have a Oli compound file, and there's a VBA storage in there, and within that storage there are the Oli streams that actually contain the macro code, then such an Oli stream, like the stream module 1, consists of two parts. The first part is performance cache, which is undocumented. There's hardly anything to find about that. In the official documentation, Microsoft actually says that this part must be ignored. Well, clearly it is not ignored in execution. And the other part is the compressed source code, which is just compression of the VBA source code that you can look at from the GUI. And this performance cache part of the Oli stream module contains what we call P-code. There's much more in that, but part of the performance cache is P-code. And what P-code is, it is a VBA version-specific pseudocode for the VBA stack machine. Well, that's a whole mouthful. But what you should know is that everything from Office 2010 onwards just uses the VBA 7 stack machine. And as Dr. Bonchev has done some really good research into this, and he shows that on his GitHub, what actually happens is the following. If you open a Word file or an Excel file containing macros, and both the version specified in VBA projects as well as the architecture, x86 versus x64, matches the version of Word or Excel that's running on the host, then this compressed source code, the actual code, is completely ignored, and VBA, and the P code is ran instead of VBA. So, to explain it really easily, again, let's open our module stream. What you see on the bottom is the compressed source code, and what you see on the top is the P code. So what you can do, if you know the exact version of Word or Excel that your victim is using, then you can just null out the compressed source code, leave the P code in there, and then actually the P code runs instead of the VBA source code. So if you then go to your analyst tool, again, the macro has completely disappeared. We're still looking into fully weaponizing this, but for the time being, it's not that difficult. You develop your malicious document in two branches, x64 and x86. Then you open your malicious file in a compound file editor like FlexHex that I'm using, and then you go to bytes 3 and 4 of the VBA project Oli stream, and you just make sure that the version number that's in there matches the version number of your victim. And we'll soon publish a small table with correct version numbers to do that. We're weaponizing it, but it definitely can be used in offensive operations. Okay, that concludes the explanation of the first trick. I see some hands being raised. Let's do the questions afterwards, if that's okay with you. Thanks. If you thought this was fun, this was our basic trick. So I'm going to invite my fellow magician, Peter, to continue with the second trick.
So, a magic show should include cutting someone in half, right? That is the definition of a magic show. Well, for Stan, luckily, I'm not cutting him in half, we're cutting other things in half. Let's move directly towards a demo. Let's first close Stan's Word instances. So, suppose we're sending an email to our victim, a phishing email, with a link saying, here's an interesting Word document, please check it out. And that victim would end on a page like this. Well, in a real story, it wouldn't be like this page, but let's click a link, demo 2. Well, what we see is 2 downloads being generated. So let's check our downloads directory on our computer. And we see 2 files being downloaded from this website: a readme.html and a docx file. As we all know, docx files, they can't be macros. So these are 2 really certainly non-malicious files. Let's open the readme file to just see if someone messed with it. No, this is really an innocent readme file. It states there, so it must be. And then we open this file, which is also named innocent, so that one is probably innocent. And we downloaded it, so it will open in the protected mode. So in the protected mode, we click Enable Editing. And then suddenly, we get a security warning for macros. And if we enable that, we just pop the box. So we did a macro in a docx file. Hell yeah. But this is a magic show. This is not what we did. This was the illusion. I mean, really a macro in a docx file? No, I can't do that. But I can make the impression, as you just saw. So how we did that? So the first step to learn is about Office documents and templates. So Word documents can have a template, have reference to a template file. And typically, this is undefined, and then your Word document refers to normal.dot. But you can make an explicit template, and you can use that, for example, in a company, if you have like multiple brands and logos, etc., you use explicit templates and say, well, use this font for this document, use that one for that document. Templates can also include macros, and if you open a document, and the template will be loaded, and the macro events, the auto-open events, will fire. And there is a full path, just somewhere in the XML of a docx file, in the Word Rels settings XML. It's just a full path of this template file. So this is a basic. But there are some properties of these templates that we can build upon. So if Word can't locate the template, it will start looking for the template, just the last part of the file name, in the current directory. And if the template is not found, there is no error. Word just then points to in the GUI, and the document itself is just rendered with a normal.m file. This is kind of intended if you have your templates on a network share and you have a laptop user, then you still can open the document, no errors, but the document is just rendered a bit differently. Interestingly, Word accepts a rename of a dot file, which is the old school template. You can just rename that to any extension, and Word just accepts that.
You look thirsty.
No, I'm
I am.
yeah.
He's like, no.
No, I'm sorry, I'm in a terrible jet lag, so I'm like.
Help you out with that. Have your vegetable.
That would be excellent.
Drink it when I'm talking.
Yeah. So we can rename it. We can rename templates .templates, so not .x or .m templates, but the old school templates. We can rename them to any extension, and it's being accepted. So what you just saw was a docx file with a template reference to just a path on an normal computer to a readme, which ends on readme.html, and then and then on the computer this readme.html file was loaded. But wait a minute, I opened the readme.html file, and it was an HTML file. And now I'm saying it's a template file. What's going on here? Well, this is a polyglot. So the template is this binary compound file Stan just mentioned. It's just a binary. We leave the header intact, and afterwards we just insert an HTML comment tag. And at the bottom of the document, we extend it with the close tag and some HTML with JavaScript, which says, well, the body of this document is just this innocent message. And Word accepts this. The binary compound file doesn't crash, crash Word, so this is just apparently interpreted correct. So now we have these 2 documents, but we need to kind of deliver them. I mean, this only works as long as this template file and this docx file are in the same directory. So we need to bring another a trick or step in our attack chain. And for that, we used a friend which is called HTML smuggling. HTML smuggling is a technique we often employ to bypass proxies. The idea is the following: instead of serving a file on a file server, you serve an HTML page which has some JavaScript code, and the JavaScript code has a big base64 string, which is the real file you're serving, and then you within JavaScript that generate binary blobs and make them available as a download link, and then with JavaScript you click the link. This is something we often use to bypass proxies that do sandboxing, because we don't have any files over the line. But as this is JavaScript, we can use this and run this just run this twice, and as such generate 2 downloads. So Stan made an excellent write-up on smuggling. It's not something we invented, but it is really a cool technique, just besides of the Office stuff. So this completes the trick. So we have a website which generates 2 documents. The documents, one is a README file, which is a polyglot with with dot and some HTML content, and then the docx file that really loads that template. But there's much more in this line of field if you look into the templates. We often employ them for offensive purposes. So suppose you have a company that has configured the trusted locations in Word for a network share. So companies do this, so all the documents on that network share are automatically approved. The yellow bar is no longer needed. And there is maybe a valid reason for them. They don't want to train the users to click the yellow bar. So they put them on a trusted location. And we see this very often. And then for us, the trick is to find someone or somewhere where we can write. And if we can write there, we could just drop a docx file. But then we need to lure a user towards that. That's kind of tricky. So, and the other thing is, these are kind of tricks where we don't know if the defenders are looking. So they may be doing periodic checks on these file shares. Is there something happening there? So one of the tricks we can do there is we copy just our evil dot file, but we now rename it, we move it to this network location, but we now rename it thumbs.db. Well, that's certainly not suspicious. No one will check the thumbs.db. Then in our own lab, we will prep a file, which is called invitation.x, and we will just include a full reference to a pod.
That should be .x instead of docx. Or dot.
No, it should be doc. Sorry. And then we just send one email to a domain admin saying, "Dear domain admin, there is this event. It's the Christmas event. Could you please participate?" And this email will pass the proxy, will pass spam filters, because it is kind of a legit email. The document itself, it doesn't have any payload in it, because the payload is already on the network. So we can, this will most likely be executed. The only thing now holding us back is this protected mode, but with some social engineering, the guy will really click. I mean, if you just make the document look convincing. And that brings us, so that could directly from just one writable file access, doing an outside email, bring domain access credentials, domain administrator access credentials in our hands. And the nice thing is that for an investigation, this is really hard to track, because you see emails on the outside and you see mails dropped on the inside, and somehow they are connected. So if we apply this, like the blue teams, they don't know where to look for, because it's so hard to detect these kind of tricks are going on. But we're not always that lucky. I mean, we see these trusted network locations in about half of our engagements, but it's not always that kind of luck. So then there's always this idea of backdooring legit documents, so just taking a file share and backdoor the documents on them. But if we would just backdoor documents, we kind of have problems. People copy, just employees or users copy Word documents, copy Excel documents, and we don't know where they end up. So our virus ends up everywhere. So we want to have control. And if there's something suspicious and someone forwards it to the blue team or the SOC, we're not really happy with that way of working of backdooring a legit file. So what we do is another trick. We copy an empty .file or .m to just a random file share. And on that random file share, we set the permissions. We uploaded the file, so any user in your domain can do that. He is the owner of the file, so he can set the permissions. And we just say, well, this file is open to all domain users. And in a typical setup on a network, you have like two protections on how shares are secured, and the share level and the file level. Now, on the share level, typical setup is have all the domain users accepted, so everybody can now access this file. Then we start looking for interesting files. But there's a nice script, find interesting files. We'll just search for files that have been recently accessed in the last 7 days, and where we have write access. So let's just start looking for all the files that our user has that is somewhere in use the last 7 days. And what we do is we just reference all these documents to this empty dot file we just created. So nothing is changing. We're just making references. And how we do this? Well, that's the link there. Yesterday I put it on GitHub. This is a script we wrote for doing this. And the script is really simple. Unzip this doc file format, parse the XMLs, update this template location, and zip it back again. So there we are. We have a lot of files now referencing our template, and then we come with the weaponization. So we place our backdoor in this file, and then all over the place, people will get macro warnings. We get a lot of beacons or whatever we use flying into our network. And if we say, well, we're now running this for half an hour, this is sufficient, we just remove this payload from this .m file, and it's gone. If employees would forward documents to the SOC, there's nothing in these documents because it's in the template. You can even go steps further. We can control time by doing this, inserting the payload or not. We can also control the victims. I expressly said that all domain users are allowed to read this file. What if I say, well, all domain users except for the blue team? Or maybe I'm targeting this department. Let's set the permissions that only this department or this guy gets this macro warning, and all other people who open this file will just see this normal reference. So that's kind of a nifty trick. There's a lot more work to be done on these templates. We have a lot of IDs. This research is certainly not completed. I mean, including doing this by combining it with a responder and just having hashes being relayed is also a version or a variant we're thinking about. So there's a lot of future work in this area, but we think this already brings some cool tricks into our playbook.
Now let's go.
Yes?
Thanks, good, very good. Let's go to our third and final trick. Smooth as silk. And it's the oldest trick in the magic book. Because with this trick, we're only going to use techniques that are at least 25 years old. So who of you are younger than 25? Okay. So the stuff that we're going to use here is older than you guys are. And it actually still works on the most recent Office versions. So let's see what I'm talking about. We're going back to our demo environment. Let's clean up the mess that Peter left, just as I did for him. Okay. Cool. Oh, browser. Click here for demo tree. To download a file. Do you want to download demo3.slk? Wait, what? 99 bytes? Just 99 bytes? That's interesting. Let's download this file. Okay. Let's go to disk where it's been downloaded, and I now indeed see demo3.slk. If I zoom in on here, I see indeed it really is 99 bytes. Let's open the file. is really interesting. I'm not sure if you're noticing, but if you look at the warning that's being displayed here, it's a macro warning immediately. Although I've downloaded this file, which means that it should have opened in protected view, right? So for one reason or another, I'm not hitting protected view here, but I'm immediately being sent straight towards the macro warning. But I don't see any macro whatever, but I'll click. I don't see anything, but I'll click enable content, and there's my calculator. 99 bytes. Let's see where the macro is. Go to the macro editor. Nothing there. Wow, what kind of file is this? It's just an ASCII text file. That's trick-free. So what happened here? I see some puzzled faces, which is good. Let's first of all start with what a SYLK file is. SYLK stands for a symbolic link. It's a file format that has been developed by Microsoft in the 1980s. I believe it's in somewhere around 1984, which means it's exactly as old as I am. And it was introduced for exchanging spreadsheet data with other programs than Microsoft Excel programs. It's a completely text-based ASCII file format. There's nothing binary in there, it's all ASCII. And the SLK extension is associated with Excel by default up to and including the latest Office 2016 versions. Matt Nelson from SpectreOps already showed that this can be weaponized via DDE. So apparently you can use DDE in here and do execution with that, but we go a step further. But what is really interesting to note is that by design, because it is a text-based file format, SYLK files will never be opened in the protected view sandbox. So all text-based files, including CSV, etc., will never be opened in the protected view sandbox by Microsoft Office applications. So that also applies to SLK files. Okay, this is a little bit of background on SLK files, but what can you put in there? In the beginning, I had no clue. So I started looking at some simple examples that I could find on the web. This is a basic SYLK file. SYLK works with lines, and each line is called a record, and it starts with a record type, and then a semicolon, and then a number of fields that you can use after that. So let's look at this example. The first line says ID P. ID is obligatory for every SYLK file to start with. P is the field where you can specify the program that is used for this SYLK file, but you can leave it empty. And then we see a number of C records, and let's look at the first C record, for example. It says C, which means cell. This cell is located at Y1, X1, which means row 1, column 1. And then there's the value, which is defined by K. This is row 1. So we also specify row 2 and row 3 in column 1. And then we specify numeric values for row 1, 2, and 3 in column 2. And then at the last, there's the E record, which says end of the SYLK file. This is a basic SYLK file. That's pretty easy. But the question is, what other stuff can I do with a SYLK file? This took me quite some time to figure out. I got my hands on an excellent book, which is called The File Format Handbook by Günter Born. It's from 1995. And there's file formats in there that have died long ago and that I've never heard of. I could only buy it secondhand. But it's a great book. It's really a great book. So if you can get it, get a copy of it. And there's also a really ancient specification. It's a file called silksum.doc, which has been made by Microsoft, and it's floating around the internet. There's no really good URLs I can point to, but if you just Google for it, you will definitely find it. It's not a doc file, it's actually an ASCII text file that they named .doc, but that's because this stuff is so old. If you look into silksum.doc, into the specification, there is this following line, which completely caught me. Macro executable sheet. Note that this should appear before the first occurrence of a G or F field in an NN record, otherwise not enabled in Excel. Also before this first C record, which uses a macro-only function. I had no clue what this was saying, but I had just one question. Wait, what? Can I do macros in a plain text file, in a plain text Silk file? And apparently, yes, you can. So, Poppy calculator in less than 100 bytes, you see it right here. It looks really trivial, but it took me hours and hours to find this out, actually. It's just a shame if you look at how trivial the code is. So what does it do? First line is every Silk file, ID with P leaving empty. Then there's a O record with E being specified. And this means, according to the specification, that I'm introducing a macro sheet into my file. Then there's an N record, which specifies that a function named auto-open is to be introduced at row 1, column 1. And whatever comes after that, that's just disregarded, so we don't care about that. Then I introduce a cell at row 1, column 1, which says exec calc.exe. Then at row 2 I say halt, and then end of the Silk file. And if you open this and execute it, calculator pops after you enable macros. What I did in my trick is not to introduce the macro code at row 1, column 1, but the macro code, if I go there, it's probably still open, should be somewhere here. So that's why you didn't see it. Okay. So for those of you who are familiar with VBA, and that's probably almost all of you, this is not VBA. It's something completely different. VBA didn't even exist by the time that Silk files were introduced. Welcome to 92. Welcome to the world of what we call XLM macros. Wait, what? XLM macros? If you have no clue, what are XLM macros? XLM macros are way older than Clippy. Let's start with that. So if you think Clippy is old, this stuff is way older. XLM macros are actually Excel 4.0 macros. And Excel 4.0 was introduced in 1992 for Windows 3.0 and 3.1. VBA was introduced later, in 1993. So by this time, VBA didn't even exist for Word and Excel. But XLM macros are still supported in Office 2016. It gets even better. They're also supported on Mac, including in SLK files. So yes, you can do a 99 bytes process creation SLK file on Mac as well. So you can embed Excel 4.0 macros in different file formats. There's one file format which is really which was really being developed to contain this, which is XLM files, and they are actually being blocked by recent Microsoft Office version. But Excel 4.0 macros can still be embedded in sheets within modern file formats like XLSM, XLS, or ancient file formats like SLK, and that still works. So you're now probably wondering, how do I create such an Excel 4.0 macro in, for example, XLS? Let's go back to Excel. File, new. This is Excel. I'm creating an Excel file now, not an SLK file. Right-click on sheet 1, insert, and then there's this option here, MS Excel 4.0 macro. Who of you have ever seen that? A few hands. You must be old. Just kidding. Just kidding. So you say, okay, and now I have another sheet called Macro 1 right here in the bottom. Sorry, disappear, Macro 1, it says. Cool. What I can do here is say exec calc.exe halt. This is just how XLM macros work. They always have to end with halt or return. Then I can say, let's try this out. Run. I'm going to run the macro at row 1, column 1. And there's calculator. And if I want this to auto-open, I can just name my first cell auto_open. And if I save this, I have a macro in an Excel file which is not VBA. And if I want to hide this, I can just say, hide the sheet. It's gone. and it will still run, of course. So that was a basic macro. But now you want to really weaponize this, at least we do. And this was a pain in the ass, but after hours and hours of figuring out how I could map internal Windows stuff to data types that are supported in Excel 4.0, I came up with this macro. This is shellcode injection in XLM. I don't have time to explain what's going on in this code. So if you want to know, look at the block that's down there. But yes, this is the Windows 32 API being called using XLM macros. Immediately after I put this out on Twitter, there was a guy called Philip Zuckerman from Cybereason who pointed out that XLM macros are also exposed via COM and via DCOM. So this is also an interesting lateral movement option, where you can just pass the XLM macro as a string to a DCOM exposed method, which means that you can do lateral movement via XLM macros, which means that you should be able to do shellcode injection via DCOM and XLM macros. Haven't fully weaponized that, but I'm pretty sure that we will get there. So this is fun. Have a good look into it. So there's some Kung Fu happening there. And now let's get to an interesting part. How are XLM macros being stored in various file formats? Let's have a look at the compound file format. And on the left, you see a screenshot of how a regular VBA macro is stored. We've already seen this in demo 1. There's a storage called VBA, which has all these streams where the actual code is. And this is a standard file structure which is being used by every AV scanner that's out there just to extract the VBA modules and to see if there's anything malicious in there. With XLM macros, the stuff is completely different. XLM macros are just a special type of sheet that's in a file, and you see that in the screenshot on the right. There is no separate storage for macros, for XLM macros. It's all in the regular workbook OLE stream right there. And this might be one of the reasons why apparently the whole antivirus industry seems to have completely forgotten about this prehistoric technology, because I uploaded the shellcode injection sheet to VirusTotal, and yeah. Try this with an unobfuscated shellcode injector in VBA, and you will definitely not get scores like this. So this is really a call out to the AV industry. Do something with this stuff, because it can be weaponized. That's what we have shown. And right now, detection rates are way too low. Let's go one step further. That's AV. But what about MZ? Microsoft recently announced that the anti-malware scan interface now also integrates with the VBA agent on the most recent Office 365 client applications, which means that you can use a MZ provider to look into what VBA code is actually being executed without all the obfuscation that might be in there. Actually, how it works is the MZ interface catches all COM methods that are being called, and it catches all Windows 32 API calls that are being called, and it logs them via MZ to the MZ provider. But that's VBA. And the MZ provider hasn't opened up to XML. So yes, in this case, we can use 26-year-old technology to actually circumvent, I'm not saying bypass, I'm saying circumvent, the MZ provider that has been recently introduced. So actually, this whole XLM, XL 4.0 macro stuff, with the current defensive layout that we see there, is really interesting for red teamers, but unfortunately also for the bad guys that are out there. So we as an industry, we really need to do something about this. This concludes my third trick. There's plenty of work to do in this area. I've only scratched upon the surface, and there's probably so many interesting stuff in these directions that we can gather. So we as a community, as an offensive community as well, let's see what we can get out of this. Then back to Peter for the final thoughts.
So this was kind of Stan's Pandora box with these XLMs, but there's much more to come as soon as Microsoft allows us. So the tricks we demoed, we believe they're fully in line with specs. So this is kind of the desired functionality apparently. We got some other tricks as well. So we got a fishy monkey that steals your files. And we have a don't take the bait, credential stealing Word documents. And both these are 100% macro free and not these trickeries we just used, but really macro free. But we can't really talk about that because we're in the Microsoft responsible disclosure process. Updates will be released, and then we will release what was behind that and what we were actually doing there. So there's a lot of more interesting stuff coming up the upcoming weeks and months from our end. That concludes our presentation.
Thank you.
Thank you.
I remember that there was a question from the guy with the white shirt in the back.
I've got your first trick that relies on the version number matching. Is that just the major version, 2010 to 16, or is it not?
So the question is, with the P-code stuff that we have seen in the first trick, what kind of version was I talking about? And yes, it seems to be about the major version, like 2016 or 2013 or 2010, but depending on the architecture, x64 or x86. Thanks. Thank you. All right. That's a good question. What happens if you turn off macros in your environment? If I recall correctly, I've done all kinds of testing. This does adhere to the macro rules. So if you completely turn off macros, then XLM macros won't run. But there's something that we didn't mention, which you should keep in mind. Please be aware, and that relates to trick 2 of Peter, that things like trusted locations always are prioritized above your macro settings. So you can have the macro settings at completely disabled, but if you have a trusted locations, then still macros will run from that location despite your macro settings. That's something that you should keep in mind. All right, thank you all.